Now I want to open it up for questions to Stan, Jeff, David, Brian on any of these topics. Think in 7 minutes. What questions would you like to ask?
Yeah, hey, this is Andy. Brian, great work. Maybe you said it and I just missed it, but so we have everybody working on getting their GFE terrain updated. Meanwhile, Dave Myrick, you're working with the INSEP centers to get all the model users. Is this eventually going to all become unified, or are these two things on slightly different paths?
No, Jeff, no, Andy, we're working with EMC on this. All of the unified terrain data sets will then be added back so that they're used in the smart inits that EMC runs. So for example, the unified terrain is being used in the 3 models that are used as a part of the first guess in the RTMA IRMA with this upcoming upgrade. So when all of these changes are finally finalized, they'll get put back into the national blend, and they will also be added over at EMC as a part of the RTMA effort.
So maybe this is where I'm a little bit confused. So the model upgrades, is that going in as like a series of phase 1 and phase 2 then? Or are you going to wait till all the editing is done and then do it just once?
And I can't really speak for the models, Andy. Jeff may be able to. Right now, we're just focused on the RTMA IRMA and the blend.
Yeah, as far just to maybe address some of the maybe this a little confusion. We're using this as the 2.5 kilometer terrain. So for downscaling purposes or other purposes where, let's say, the NAM 12 kilometer or the NAM 4 kilometer were downscaled to 2.5 kilometers, hopefully we can use this terrain as the consistent data set. Would the NAM 4 kilometer be using this? No, I don't see that happening. The NAM has its own terrain data set at its resolution that it's run at, same with the GFS, etc. That said, I don't see, it's something to be considered for other models that may be run at 2.5 kilometers or near 2.5 kilometers. So something like the HER, it could be a consideration. But it's used mostly on the EMC side for the downscaling and for the RTMA IRMA, which is already being run at 2.5 kilometers. Hopefully that answers the question.
Yeah, and so this is a great conversation. So we're the EMC folks. You guys are not standardizing on a uniform terrain model then, or is that just something I just understood?
The problem is that if you use the finest resolution terrain, let's just say in a 3 kilometer model, or let's just say 2.5 kilometer model, the numerical model would be using say that the average terrain in a 2.5 kilometer grid cell, and even that itself is too fine because the models can't resolve anything that with fewer than 4 to 10 grid points. So if you insist on using the 2.5 kilometer terrain, then you're going to introduce alias in noise and signal that the model cannot deal with, and you're going to force the model to either filter that out, or you'll have to deal with the how it's aliased into the signal, etc. So most numerical models have some way of filtering beyond computing the average terrain for each grid cell at the grid cell resolution. So the 2.5 kilometer terrain that's used for NDFD would not really be appropriate for use in a 2.5 kilometer numerical model. Stan, you want to comment?
Yeah, that's a great discussion point. It turns out that we do use the mean value at each 3 kilometer cell straight up in the HER. But even that probably wouldn't satisfy, first of all, you have to go to 2.5, but let's say even we had a 2.5 kilometer straight up model in the HER, that won't fit the actual station elevations quite as well as the regions want. So you would still want to have something that's a little bit adjusted. I think that's what the discussion here from Brian is about, and then use that for the smart init for the last step and isolate it to that. And it's a little bit, again, like how you use the imagery data You can use that for the situational awareness at the highest resolution possible. That could even include using station elevations to get that matched as high as well as possible to the station elevations. But for the model, you can't quite do that. But the Smart Emit will allow you to address at least this terrain issue, I think.
Great conversation. I guess I've been under the wrong impression here for the last year or so. So this is good.
What were you thinking, Andy?
Well, I sort of thought, we were sort of getting into a new paradigm where, all these issues we never had to worry about when models were 100 kilometers. But now that we've got the HER running at 3 and the NAM running at different various high-resolution versions, and even the GFS running at 13, the underlying terrain mass gets to be more and more important. So I sort of thought we were unifying the modeling terrain too, but sounds like we're not. But maybe someday we probably should. It sounds like maybe.
I think we should, and that should be a topic for future discussion. But let me say again, we are able to use the marine terrain in each 3 kilometer square straight up right now. And actually, we might be making some forecasts higher up, a little bit worse. NCAR, by the way, with ARW, some of you know this, is developing kind of a hybrid coordinate that'll get smoother several levels up, but then that will be better. Having the choice that we made with the HER 3 kilometer is better for near surface short range and whatever range forecasts. And so we kind of pay a price a little bit higher up for what takes place near the surface, which is probably what you guys in the regions want.
Well, and you may be paying a price longer out in forecast range as well.
That's true, and that's part of this new ARW coordinate is probably going to help with that.
Yeah, and again, I want to be really careful here. I'm not saying we should do anything. It's just the more you think about it, as the models go higher and higher resolution, then all these different masks and the things that Brian are doing does have a direct impact on our forecasts. So it's an interesting conversation.
And with that, we're going to have to cut it short. Thank you, gentlemen. We've got Jen here who's going to talk about the MRMS, and I don't want to cut into any of her time.
Oh, Amy,
So-
Amy, can I have one quick
Well,
question?
they won't be able to hear
I
you.
think I can
I'll
drive
take it from
somebody's
here.
saying something.
Oh.
Amy, this is Brian Moretsky. I was wondering if I could ask one quick question of Stan and Jeff while they're both still on the call.
If you promise to be quick.
I hope it's quick. Stan and Jeff, your presentations, what direction is the RUA coming from? It's sort of hard to see when if the HER is improving all the time and bringing in these observations, the HER is still going to be the background to the RTMA, right, or the RUA. Is that the point?
So, Brian, you're asking why don't we just use the HER analysis straight up for the RUA?
I'm not. Yeah, I guess I don't know.
Yeah. So I guess we're putting a little bit of a line between those two for the time being because we perceive that the users want to have the the 3D RTMA, URMA, whatever. It just has to fit the OBS as closely as possible. So we, again, as I pointed out, we think that doing the RUA is actually going to help for better short-range model forecasts, but some of the parameters and the scale at which we use them can be different between the model initialization and the RUA for the reasons that Jeff and I said.
Okay, that's perfect. Yeah, I mean, Jeff is saying that they're going to go to a 3D, and I think that was the component that was sort of missing in my mind, because if you had the HER background combined with just a 2D RTMA, then it might be a little different.